Welcome to SciPy 2014, and this is an intermediate tutorial on the IPython display system and interactive widgets. I am Brian Granger, one of the core IPython developers. My co-presenter is Granger&Frederic, also one of the core IPython devs, and Jonathan has been one of the main developers who's implemented the new interactive widgets that we'll be talking about today. So it's great to have him here. So I'm going to spend just a few minutes making sure everyone is on the same page in terms of having the tutorial materials and also having IPython installed. And the first link is here. This is to the IPython in-depth repository on GitHub. And I'll visit that here. And as you can see, we last pushed about 8 hours ago. So if you grab this repository before 8 hours ago, you should grab it again to get the latest materials. And it's probably, the simplest way of doing this is just clicking the download zip button here. Obviously, if you have Git and want to do an actual checkout, you can do that as well. The notebook that we'll be using as the main sort of table of contents for this tutorial is this one here, interactivewidgets.ipynb. In terms of installation, this tutorial will be based on the latest stable version of IPython, which is 2.1. It's likely things will more or less work if you have a more recent version of that, but if you're using the latest dev version, there are some differences, so we do recommend running 2.1. We're running 2.1 ourselves. And then we have some assistance here to help you solve any installation problems. And can our assistants raise their hands? So we've got Min here, who's an IPython core dev. And, yeah, and obviously Jonathan and I can roam as well. And we may, I think we were supposed to have some other people showing up as well. So for the most part, there's sort of two main ways of installing IPython. If you already have Python installed yourself, and you're sort of an experienced Python user, and you're comfortable with pip, and you know which Python version you have installed and where it's installed, pip install IPython should work. If you're new to this and you're just getting started, we recommend that you install IPython and all of its dependencies either through Canopy, which is a Python distribution put out by Enthought, or Anaconda, which is another Python distribution put out by Continuum Analytics. And so this web page here has instructions for those. They're both double clickable installers. And then after you run that, there's commands here that you'll need to run to get the latest stable version of IPython. And John, were you able to find the link to the test script that we have?
Yes.
Yeah.
Write that on the board.
Yeah, if you can just write that on the board. So we also have a script that you can run at the terminal to test the version of IPython that you have installed and make sure everything is set up. And so at this point, how many people here are confident that you have IPython 2.1 installed? I just want to get a rough sense. Fantastic. All right. That's great. So again, if you have questions as we get started, just throw up your hand. We'll notice and we'll come around. Another important way to get help is through our HIP chat channel. And so if you go to IPython's website, ipython.org, and go down on the right-hand side, we have this link, Help Chat Room. If you click on that, it will take you to HipChat, and it will look like this. You'll be able to do an anonymous login. You won't have to create an account. You can just enter any name you want. and that'll take you to our help room. And there you go. You can see you're finding out about this. And we will, those of us on IPython who are not presenting will be monitoring this, and we can answer questions there as well. That's a fantastic place to get sort of real-time help as well. So we've got that. We've got that. And I think that's everything I was going to cover. Let's let John finish writing up that URL. And I guess I can mention a few other things. So So there's some other IPython related talks here at SciPy. This afternoon, Min, and I think Fernando's going to help out with this, is going to be presenting about parallel computing with IPython, and that should be a fantastic tutorial there. I think, well, actually, so David Ketchison is also going to be talking about teaching numerical methods tomorrow with IPython notebooks. And then there's a number of talks throughout the conference related to IPython as well, so you can check those out on the schedule. And so this URL here, you can go there, and there's a script if you want to run that just to be sure, make sure that you have IPython 2.1 and that everything's ready to go. And with that, I will give it over to John here, who's going to cover some of the basics.
Thank you, Brian. Let's see if I can. Hey, Brian, do you know how the mirror?
Yeah, you can go to System Preferences Display.
Arrangement. Mirror. Perfect. Okay, just to make sure that we're all on the same page, we're going to go over some of the basics. So what is the IPython notebook? The IPython notebook is an interactive computing environment. It allows you to run code, create interactive widgets, plots, narrative text, equations, images, and video. The documents themselves are self-contained. They have a complete history of your entire computing. And then you can take those documents and you can share them with other people. IPython is made of three major components. There is the kernel, which is the back end, the front end, and the notebooks themselves. So here's a little drawing that Brian created. It's kind of like a little XKCD drawing that kind of shows you the front end separated by the kernel. And in this tutorial, we'll talk about the kernel as the back end and or the kernel kind of interchangeably. So the notebook web application itself is what you see in the browser. It allows you to edit code, run code, and see results of your computations as rich multimedia representations. So like HTML, JavaScript, JSON, videos, pictures. It also allows you to have interactive widgets, author narrative text, build hierarchical documents, so you can structure your documents with different header levels and then later use that information to do special things with your documents. And it allows you to embed math using LaTeX. and start parallel computing clusters. So the kernel itself is the thing that's actually running the code that you enter into the notebook. A kernel is designed to run code in one language. Some kernels, like the IPython kernel, have special functions that allow you to outsource a little bit of code to a different language. The IPython team works on the Python kernel officially, but there are a bunch of other third-party kernels that are out there, so like Julia, R, Ruby, Haskell. This list is not complete. There's obviously a lot more than what's here. So the notebook document itself is what contains the inputs and outputs. The inputs are the code that you type. The outputs is the results of running that code. They also contain the widgets in a separate widget area. And when you save your notebook documents, it's actually saved as a flat file on your local machine. And that file you can send via email or upload to GitHub, just like any other file. There are 4 different types of cells in IPython notebooks. There are code cells, markdown cells, header cells, and raw cells. We don't talk about raw cells as much, but they're used for including MIME type data to be exported to different formats. Internally, everything's stored as JSON. This is nice, so you can actually view the raw notebook files. It's not a binary format. We say this is diff-friendly. In practice, it's still a little hard to merge. There's actually a tool out there now that will help you with that. And lastly, anything that any notebook that you create, you can upload to github.com or to any public HTTP server and take that URL and you can paste it in a website called NBViewer. And NBViewer will convert that notebook into a static representation that you can then share with your friends. And this is cool because your friends don't have to have IPython installed, so this works for anybody. So on to the notebook basics. So to start the IPython notebook server, you can run IPython notebook from the terminal or command line. The first thing that you'll see is the notebook dashboard. The notebook dashboard is a list of folders and IPython notebooks. You can enter into a folder by clicking on it or open a notebook by clicking on it. At the very top, you'll see a breadcrumb. Breadcrumb allows you to navigate up a directory. There's a running tab and a clusters tab. The running tab allows you to see what notebooks you have currently running on your machine. And the clusters tab allows you to start IPython clusters. So the notebook UI is split into 3 main pieces. There's the menu bar here, which I'm hovering my cursor over, and then the toolbar and the notebook itself, which is at the very bottom. In IPython 2.0, we introduced a modal editor. This allows you to easily execute large commands on the notebook as a whole or edit individual cells. So you can tell if you're in edit mode by a green border around the cell that's currently highlighted. When you're in edit mode, you can actually modify the contents of that cell. If you're in command mode, there'll be a gray border around the cell. You can enter edit mode by clicking return on a cell, and you can execute or exit edit mode and enter command mode by clicking escape. If you note here, when I click escape after being in edit mode, it doesn't render. That's also a new thing in Python 2.0. If you hold control and click enter, that will render the cell. Shift-Enter executes the cell and moves down a cell. So, and if you're at the bottom of the document, it'll create new cells. So Control-Enter just does it in place. So everything that you can do with the keyboard, you should be able to do with the mouse too. So by double-clicking on a cell, it enters edit mode. By clicking cell run, we can execute that cell. Or by just clicking outside of the cell somewhere in the blank area of the notebook, we can leave that cell unrendered and enter command mode. So if you ever want to see what the list of commands are in command mode and edit mode, you can go to help and then keyboard shortcuts. It brings up a little dialog. And you'll see there's two separate sections, command mode and edit mode. There are some basic commands that you should probably learn if you're going to be using the notebook a lot, like the basic navigation, Shift, Enter, up, K and J also work as up and down. Saving the notebook, Control S still works, but if you're in command mode, you can just click S. And then converting between different cell types. Y is a code cell, M is markdown. 1 through 6 are different header cells, and T is a raw text cell. So I have a couple exercises here. So if you look inside the IPython in-depth directory, this is part of the tutorial material, and click on the interactive widgets index file. Under introduction, there are notebook exercises. Go ahead and open that. You'll get a notebook like this. And these are a couple things just to make sure that you're on the same page as us. Go ahead and try to do number 1. So in this exercise, you'll create a cell and cause the cell to sleep, and just verify that this indicator up in the top right-hand corner becomes dark. And what that means is that the kernel is thinking. So as these 2 seconds are going by, you see that indicator is dark. Once it's done, it becomes empty like that. So I'll give you guys a couple seconds to do that, maybe like a minute, 2 minutes. Oh, it's getting cut off. Sorry. Yeah, is that a little bit better? Sorry about that. I don't know. Okay, I see you.
Center of the notebook directory.
Yeah. Notebook exercises.ipynb. So it should be under IPython in-depth. I think it's exercises, and then notebook space exercises. Yeah, there's an exercises directory and then an examples directory. It's under the exercises directory. How's everybody doing? Are you guys ready to move on? Or? Okay. On to the next exercise. If you can go into the notebook that you created in the last exercise and just try moving the cell up and down, copying and pasting, and merging and splitting the cell. Yes, I've had that problem too. Like, especially with the Retina screen, like sometimes the top disappears. I think it's a bug that we need to fix. So, but I have noticed that. And
there's another way to.
You can actually change it. And so there's something called a custom CSS, and we load that. It's stored in your profile directory. I think under it's like HTML static. And then if you just have a custom CSS that's sitting in there, you can set those attributes and just thicken the border. But there have been a couple of people that have suggested that already. We haven't really made a decision whether or not we're going to thicken the border at all. But my vote is for yes. So I'm going to go ahead and demo this problem. So if you hold Control and then click J, actually you have to be in command mode. So you see I'm in edit mode. So if I click Escape, then I'm in command mode. If I hold Control and click J, I can move the cell down. If I hold Control and click K, I can move the cell up. Simply clicking C, I don't need to click Control C, just clicking C, I can copy the cell, and V will paste it. Same thing with X. X will cut a cell, and V will paste it. And by holding Control Shift dash, I can split a cell into two pieces. So moving on, the last part of these three questions. Go back into the last notebook and repeat some of those cell operations using keyboard shortcuts. That's what I just showed you how to do. I guess you could go back and do it using the menu. So there's, under Edit, you can split a cell, cut a cell, copy a cell, and paste the cell. I'll give you guys like a minute to make sure that you can do that. I don't think so. Not on the notebook level. There are on a cell-by-cell basis we have an undo stack, but individual undo stack, not on the notebook level. Just I think we have one. Yeah, I think we keep one action. I don't know if split is captured. Let's see. No, yeah, split's not captured.
Yeah, I couldn't find one. So.
Yeah. Yeah. There is a merge. If you do merge cell below, I mean, it's not an undo operation, but it does revert.
Yeah, I was just
Okay, on to the last exercise of the basics, restarting the kernel. This is very important. If your kernel hangs, you'll find that you won't be able to do anything. The notebook will still be responsive, but trying to execute code will just put it in a queue and it will never get ran. So if I go up here and I increase the sleep time to 20 seconds, you'll notice that I can't run this cell. So if I click this little restart button, it can restart the kernel. And then I can run that cell. The up at the top, there's this little circular restart button. And also under the kernel menu, there's a restart link under the kernel menu. Yeah. Either of those will work.
To interrupt for a second. So Aaron is bringing around sticky notes. If you have a question, just put it on your laptop. Above the screen, just like this.
Why would you do the restart as opposed to the stop?
You can interrupt it too. Yeah, you can interrupt it too. I mean, only as a last resort you do a restart. So that's a good point. You can just interrupt to stop the kernel in its tracks. But if you're in a different, like if you're in a C library, sometimes it doesn't work. You can't. The signal doesn't propagate correctly. But yeah, that works for this case. That works.
So if you wanted to go back and clear your workspace, restart kernel.
Get rid of all the variables. Yeah, and you would have to rerun everything. I mean, it's really last resort kind of thing. Yeah. No, I think it's just one. Min, do we keep? It's just one, right? We only. Okay, yeah. We just keep one, unfortunately. But yeah, there are checkpoints. That's your best chance for survival. It's just loading an older checkpoint. So closing the notebook and reopening it. What? I don't. It's not on my schedule. Maybe Brian would want to talk about that. Checkpoints. Do you want to talk about checkpoints? Notebook checkpoints.
I think that's actually outside the scope of this tutorial. We can, if you want to come up at a break or something, we're more than willing to talk about it. But one thing we're trying to balance here is this is marked as an intermediate tutorial. By the end of it, we will be moving very fast and very difficult topics. We want to spend a little bit of time getting people up to speed, but this is definitely not a sort of intro to the notebook tutorial. But yeah, all I will say at this point is that the notebook does have saved checkpoints, and so there's some protection that if you're losing work, how it works exactly is just on top of it.
Okay, I think that's it for my section. Brian, do you want to come down and talk about the rich output?
All right. So the next notebook we're going to go over in the next section is the display of rich output formats. And conceptually, this tutorial, there's really two things we're covering. One is this rich output system, and the second is the interactive widgets. And I think it's important to keep these two ideas separated in your mind. And the reason it's important is that from a user perspective, there's a lot of things about the interactive widgets and the rich output that will look exactly the same, right? Both of these things will put rich multimedia type things below your input, sort of in the location where you expect output. The big difference between these two things is that the interactive widgets allow interactivity, right? So there'll be buttons to click on, sliders to slide, whereas the rich output will just be static, rich content, maybe an image, a video, inline HTML. And the important thing is that the architecture for these two things, while it's built on top of the same foundation, is actually fairly different. And so we'll be talking more about that architecture. So let's start out with rich output. So in Python, objects can declare a textual representation through one of two special methods. One of these is double underscore str double underscore, and the other one is double underscore repr double underscore. So if you have a Python object that has one of these two methods, if you print that object or return it from an expression, there's machinery in the internals of Python itself that will detect that. We'll call that method, which computes the string representation, and we'll display it. For example, if you're in IPython, the terminal-based shell, or just standard Python's shell, you'll see the output of that. And in IPython, we've extended that idea to allow objects to declare non-textual representations. And the formats that we include or that we allow are HTML, JSON, PNG, JPEG, SVG, LaTeX. In 2.1, we've added formal support for PNG, and we're slowly adding a complete way of handling basically any MIME type. Some of that infrastructure is already in place, and we're doing some additional things that will be showing up for the next release of IPython. And so the first thing is how to display these other representations of objects. And that is the display function. You can import this as shown here from ipython.display, import display. And the idea is that display is just like print, but for these rich representations. A few important points here. Calling display on an object will compute and send all possible representations to the notebook. So let me give an example of that. So let's say you have an object that has both a LaTeX representation and a PNG representation. if you pass that object to display, we will compute both of those representations. When it comes back to the notebook, the front end, the web application, makes a decision about which of those two representations to display. The general rule is the notebook will display the richest, in quotes, representation. Richest in this context is determined by a static list of representations, an ordered list in our JavaScript code. Currently, it's not very easy to reorder that. But the basic idea is that we consider JavaScript to be the richest representation, then HTML, I think LaTeX is next, and then some of the image formats. And then the bottom is the standard textual representation. And all of these representations are stored in the notebook document. And this is a point where I think there's been some confusion, and we probably haven't done a very good job of communicating our philosophy on this. And the idea is that when you're doing a computation in the notebook, you have no idea where you're going to eventually want to use that content, right? For now, you're working with it interactively, but 6 months from now, you may decide, oh, I actually want to convert this to a LaTeX document and a PDF. Or you may say, actually, I want it in Markdown, or I want it in static HTML viewed on NB Viewer. And the reason it's important to keep all of these representations in the notebook format is that allows you to build content that can be easily converted to any of those different formats appropriately. For example, if you're an NB Viewer, you may want a really rich JavaScript representation that can actually have some level of interactivity. If you convert that same notebook to PDF, obviously JavaScript does not run in PDF. Well, it may run in certain contexts in PDFs, but in general, you're not going to get the same JavaScript experience in that context. And so there you might want just a LaTeX representation or a static PNG representation. And so that's why we keep all these representations. But it is something to be aware of. If you happen to be using an object that has a lot of representations and they're all really big, you're going to have a notebook that contains all of that, and the notebook will grow in size. If you want to display, compute, display, and store only a single representation, we have these other functions that are basically display underscore and then the name of that representation. So display underscore HTML, display underscore SVG. These work just like display, but they only handle that single representation. Display pretty, so pretty is sort of an enhanced textual representation. This has actually been in IPython. The pretty representation has been in IPython for a long time, even before the notebook. It more or less is our textual representation. Yes? There's a couple different ways of doing it. The simplest way is to go to Cell, All Output Clear, and then click Save. I mean, I know of other people that only want to clear that output before they commit and push to Git, and so they'll put a Git commit hook in that has a Python script that does something like this. If you want to do this from the command line, NB-convert, which is our general notebook conversion tool, can be made to do this type of thing. It basically knows, it has a pipeline where it can transform notebooks to other formats and to other notebooks. So you can say, convert this notebook to a notebook and put in a preprocessor that removes all of the output. So there's also that as well. And I'm really puzzled about why my kernel is hanging. Let's see what we... Better? Okay. All right, so let's look at how you can get started with rich output. So the simplest way of working is to use some of our built-in display classes. So we have classes that already have these special methods defined on them. So here's an image class, IPython.display.image, and we'll import that. And then if we pass a file name of a local file that has a PNG image to that, we have a Python object. And if we return that object from an expression, it triggers that display architecture, computes that PNG representation, sends it back to the browser. We detect that. And in this case, this object also has a textual representation that was computed. It's not the richest representation, so we don't show it. It is still in the notebook. So when I save this notebook and use it in different contexts, that will be present. Or you can pass the object to the display function here. So here we do display I, and we get the same result. The advantage of using display rather than just returning it from an expression is that you can call display many times in a single cell. So for example, if you have a loop, and inside the loop you're making, building some object that has a PNG representation, in the middle of that loop you can call display on that object, and you're going to see each time the loop iterates, it will print that out. So it really works just like print in that respect. Whereas this, you really can only return one object from an expression using that approach. Yeah?
So quick question, so when you turn it from an expression, I'm assuming there's a double underscore rubber equivalent for display creating, display HTML, and all that kind of stuff?
Yes, and I will be covering that here shortly. Sort of what do these special methods look like, and how you can define those on your own objects. And the low-level machinery in the Python interpreter that handled this is called the display hook. And basically, the display hook is a function that you can register with Python that gets called anytime you return an object from an expression. That display hook actually gets past that object, and you have a chance to do whatever you want. The default display hook for Python obviously basically calls repr and just feeds that textual output to standard out. The image object also has a URL keyword argument. So you can pass a URL here of an image that's somewhere available through HTTP. And we also have an SVG object that can handle SVG images, right? The general way to think about the image object is that, or the SVG handles the vector graphics of SVG. Image handles formats such as GIF, JPEG, PNG, etc. Yes, I mean, it's possible to combine them. The important thing is has to do with how we append those elements to the DOM. Sort of the handling logic is very, very different. SVG is actually itself really just HTML, and so we just take that data and we directly append it to the DOM. Obviously the images are thrown in an image tag with a data URI. So in principle, we could have, I suppose, handled them the same way, although it would have required sort of switching the different representations on and off depending on the format. Yeah. Yeah, I mean, the other thing that is important, and we're not going to talk about it too much, is that there are security considerations with SVG, and we treat it differently than image data in a significant way, and so there's that as well. So embedded versus non-embedded images. And actually, so I cleared my output, so this is not going to show. So when you build one of these image objects, from a file name, for example, we actually ship that image data to the notebook, and the notebook saves that image data in the notebook document. So if I then email you the document, when you open it up, even before you run anything, you're going to see that image. If you pass the URL argument, that's not the case. The image will not be embedded in the notebook. The only thing that's embedded is the HTML image tag, which has a link to the image that's somewhere out there on the internet. It's also possible to specify a URL and have it embed it using an embed equals true flag here. So this is a sort of a minor point about the image object. So if you're ever using the image object in a context, and sometimes the images are not being persisted to the notebook document, this is likely the source of that problem. Next is the HTML representation. So we have an object, it's called HTML, and the HTML object takes a string of raw HTML content. So here's a Python string that has HTML, an HTML table. Here I'm going to pass that string to the HTML object, and then we can simply call display. And again, display detects that special representation, it computes it, brings it back to the notebook, and we display it in the notebook user interface. This is a perfect example of content that is not going to show up when you convert this notebook to a PDF document, right? Our notebook conversion machinery, which is, again, NB convert, we're not going to have time to cover that in this tutorial. We try to convert output between different formats, but again, we have a limited ability to do that. We also have an HTML cell magic. A magic in IPython is any code cell that begins with a single or a double %. And this is a special syntax that the IPython Python kernel has, and it allows non-Python syntax to go into a code cell. And the idea here, I mean, if you want to think about conceptually what this syntax does, double %HTML basically takes the rest of the content of that cell and passes it to a function that itself builds an HTML object and then displays it, right? And so in this case, I can just run that cell, and you're going to see the same exact result. JavaScript. So in some ways, it may not be obvious that JavaScript is a visual representation or can be a visual representation of an object. However, because JavaScript can manipulate the browser's DOM, it can have visual effects. And because of that, we consider it in our display system to be a rich output format. We have a JavaScript object, and that JavaScript object takes a string, and that string should contain valid JavaScript code. So here we're calling JavaScript's alert function, and we pass that to JavaScript. When we display that, that comes back to the browser, and we run that JavaScript code in the context of the notebook, and more specifically in the context of that particular cell. And so here we see the alert message that you would expect. We also have a JavaScript cell magic, so double % JavaScript. You can then just type JavaScript code, and you're going to get the same exact result. And this is where the boundary between interactive widgets and rich output does become a little bit blurry, because you can actually build rich output that has interactivity. A fantastic example of this is Jake Vanderplas's MPL-D3 library, which converts matplotlib visualizations to D3, interactive D3 with interactive pan and zoom in the browser. Those also work on NB Viewer, and that uses this capability to display JavaScript in output. in this context, I would say the thing that distinguishes rich output from widgets is that rich output is only a one-way street. It takes data that's in the kernel, sends it to the front end, and that's it. Data won't ever really be sent back to the kernel in a rich output like this. Whereas in a widget, there's a two-way bidirectional communication between the front end and the back-end kernel where the Python code is running. And so that allows for a lot more interactivity, and in particular, it allows for interactivity such that a user-driven event in the browser can trigger the execution of more Python code, whereas rich output lacks that feature in general. So, but you can do really nice things with JavaScript output. And so here's an example that just runs one of the standard d3.js examples in the notebook. So here's a JavaScript object. I'm using jQuery's getScript function to load D3 from CDN. And notice when I did that, I see an output prompt here, but there's no visual output. The only thing that really happened there is that library was loaded behind the scenes. And then I'm going to run an HTML cell that puts some CSS on the page. And really, here's where you start to see the power of the notebook being just HTML, JavaScript, and CSS. We styled the notebook using CSS. And so you can style content yourself using CSS. And so I'll run that. And then here, this is a little bit more complicated. I don't expect you to understand this. But we basically just took a standard D3 example, and the only additional thing we had to add was right here. And that is when this JavaScript code is run, we need to get a handle on the DOM element that we want to put that D3 visualization into. And the local scope that JavaScript code is run in has that object, and we call it element. And so I can get a handle on that. And when I run this, I'm going to see that the actual D3 visualization here, right? And so, if you're interested in exploring D3, you can write HTML, CSS, and JavaScript in the notebook and see your D3 visualizations in line. Another thing that's important here is that the data that I'm pulling for this visualization is stored at this location, right? So it's actually stored in a data subdirectory that's adjacent to this notebook in a JSON file. And I can just give the URL here. I don't have to create a separate web server to host that data separately. The notebook knows how to serve that content for this context. So LaTeX. So we have two objects that have a LaTeX representation built in. The first is math. The second is LaTeX. The difference between these two is that for the math object, we automatically add the LaTeX delimiters. So in this case, it would be the dollar signs around this. And so when we run this, again, we see in the browser the LaTeX math rendered. The notebook renders LaTeX using the MathJax library, which is a JavaScript-based math LaTeX renderer. It's important to note that it does not render the entire LaTeX spec, basically just the mathematics. So you can't pass an entire LaTeX document with sections and subsections and all sorts of crazy things. It's basically just math. Here's an example of the LaTeX command, and notice here we're providing the delimiters, the begin and end equation array ourselves, and so you can do more complicated equation environments using that approach. And we also have a %% LaTeX cell magic that you can use to do this as well.
Is that still using D3, or is that calling out the full LaTeX? Sorry, is that still using MathJax?
It is always using MathJax. Yeah, in the notebook, if a raw LaTeX representation gets to the notebook front end, we always use MathJax. The only situation where MathJax is not used for the representation is if a backend Python library, instead of returning raw LaTeX, calls out to an external LaTeX engine, gets a PNG or JPEG, and sends that back instead. An example of a library that can do that optionally is SciPy. So SciPy, you can actually configure how it will handle LaTeX representations. And one of those options is to call out to matplotlib's LaTeX rendering. Another is to call out to an external LaTeX program. And then obviously it can also do the raw LaTeX that's handled by MathJax at the front end. Yeah? SYMPY. Yeah, it's a symbolic computing, symbolic mathematics library for Python. And I think there's a tutorial on that here this afternoon. So, yeah. Audio. So IPython makes it easy to work with sound interactively. We have an audio display class that allows you to create an audio control that's embedded in the notebook. Underneath the hood, this audio representation is just HTML. We're using the HTML5 audio capabilities. And so here, I import the object, and then I'm passing a URL to that. And
thank you for installing Express Dictate.
You can see, you can play the audio. This audio object also has built-in support to handle audio signals that are encoded in NumPy arrays. So here's an example of we're taking two sine waves of slightly different frequencies, and we pass that here. Data equals that NumPy array. We have to specify the sampling rate. When we run that cell, we get this, and you can hear the beat frequencies between those two signals. And so this is really nice, right? If you're doing work with audio, you have access to both the ability to play the audio, but also to do any computation that you could imagine using the full set of Python libraries for signal processing. Yes?
Do you have anything that allows you to select snippets out of that, or instead of just playing a window or just have that variable?
We don't. I don't know if the HTML5 audio handling has anything to do that. If it did, we could easily expose that through the audio object. Yeah. Yeah.
Firefox was just recently talking about adding a developer tools little audio interaction studio stuff. I don't know. So it probably is not in HTML5 yet, but
yeah.
it might be conceivable to figure out a way to wire the two together.
Yeah. So the potential to do cool things is, I think, pretty amazing. One example, there's a new spec called Web Audio that provides JavaScript access to the microphone. And it wouldn't be difficult at all for someone to write something that works in the notebook that allows you to record audio and have it then available as a NumPy array. Like that wouldn't be difficult. It's sort of just waiting for one of you to go home and work on. So, yeah, this is, yeah. Yeah.
Is this widget then, or is this rich display?
This is all rich display.
So how would you get the NumPy array box?
You'd have to use widgets.
Right.
Yeah. We'll get there. Yeah, so we also have a video object, or some video objects. The main one is a YouTube video object. So if you go and find a video on YouTube that you like, at the end of the URL, there's this ID. If you take that, paste it here, pass it to the YouTube video object, you get an embedded YouTube video. Again, underneath the hood, this just uses an HTML representation. And so this is a video that was put out by the White House for the first annual White House Hackathon in 2013. And there's a screenshot of an IPython notebook there. So we were very happy about that. it's important that another distinction between rich output and widgets is that as of today, if you have a notebook that has rich output, you post it somewhere on the internet, and then people view it on NB Viewer, the rich output will show up, right? So if I posted this notebook on GitHub, this YouTube video would be right there in the static version of that notebook. Today, widgets do not show up on NB Viewer. In the future, though, that's basically what John has been working on for the last few months. We're hoping that in the next release, we'll have at least some version of that working so that you can view the widgets on NB Viewer as well. It's also possible to sort of hack your way into displaying other formats. So here, for example, I have an animation that is stored in a local file. I read that, base64 encode it, and then put that in an HTML video tag here. I'm setting the source tag, and this uses the so-called data URI specification that HTML provides, where you can basically embed the content that should be in that tag in the tag itself. And when I then display it, I actually can see a version of this embedded in the notebook. You can embed external websites. We have an iframe object. Here's IPython's website embedded in the notebook. This is something we actually use a lot in presentations if we want to talk about different websites. The only thing to be aware of is that there are a lot of sites, GitHub is a perfect example, that disallow iframe embedding. So you would not be able to embed a GitHub page in a notebook. Links to local files. We have a file link and file links object. So file link here. Here's a notebook. If I click that, it provides a link in the notebook. And if I click on that, it goes to that file. So that's a way of generating, algorithmically generating links in your notebook. There's also file links, which works with entire directories. So here I can actually create links to all the files in that current working directory. So a little bit about security. So it's important to note that the IPython notebook allows arbitrary code execution. Not only allows, I think that's maybe a little bit misleading to say allows, it encourages it. Right? That's the entire reason the notebook exists, is arbitrary code execution. And it's slightly more complicated than that, though, in that you can run Python code in the kernel, but as we've seen now, that Python code can have objects that have JavaScript representations. That JavaScript code is brought back to the front end and run in the context of the notebook. It also turns out that that JavaScript code can call back in through our architecture and run code back in Python. So you can have JavaScript code that runs Python code that runs JavaScript code, et cetera, et cetera, et cetera. And this creates additional security problems. And to protect against these risks, there's a number of things we're doing. So when you run code in a notebook, and by running code in a notebook, I mean you explicitly do Shift-Enter, or you click this play button right here. So there's an explicit user action where you say, in your mind somewhere, I want to run code. The second you do that, anything can happen, right? You could have just run code that launches a nuclear strike against someone, that does rm minus rf $home. But that shouldn't be surprising, right? Any Python script that you run at the command line using any tool whatsoever could do that as well, right? So that is the way that you tell the IPython notebook, I am aware of what I'm doing, I trust the code that I'm running, and yes, I want to run it. It can run both Python code and JavaScript code. When you open a notebook, however, you have not provided that permission to the notebook yet, and our commitment that we're making is that it won't ever run code at that point in time, right? So when you open a notebook, JavaScript code should not magically run. Because that JavaScript code could run Python code, which does arbitrary things. There's one situation where opening a notebook will allow that JavaScript code to run when you open the notebook. And that is if you have trusted a notebook. And our notion of trust is that if you yourself have run previously every cell in that notebook. And the way that we track that is by signing the content of the notebook. And I don't want to go into the details of how we do that, but there's a link here to our security model. This is new in IPython 2. And so if you're ever in a situation where sometimes your rich output is showing up on the page when you open it, and other times it's not, it's because of this issue of trust, right? If you get a notebook from someone else and you've not run every cell in that notebook before, you're going to have to rerun those cells to see that output. If it's a notebook that you've been working on and that you've already run all those cells, we track that and we will know that it's trusted. Next time you open it up, all the rich output will show up. Right? It's quite subtle, and we're trying to make it as simple as possible for users without exposing you to huge security vulnerabilities. Yes?
Clear output untrusted.
So you're talking about,
Untrusted.
so you're talking of how are you clearing output in that context? Through the cell menu? The cell menu, I don't think clears the trust. I think we will still track it. Basically, I mean, you can imagine what we do. Every time you run a cell, we set a flag that tells us that cell was run. Anytime the notebook is saved, we ask, do all cells have the trust flag set? If they do, when the notebook is written to disk, we sign it cryptographically, and that happens. That's independent of whether or not there's output in that cell or not. The other form, so the rich output formats that are problematic from a security perspective are more or less JavaScript and HTML. SVG is also in that category. And we do make an effort, I should say, if we can determine that HTML doesn't have nasty things such as embedded JavaScript code, so if it's just a simple table or a bold tag or something, we will display that. And so there's some subtlety here. I just want you to be aware of the fact that when you're doing output, you have the potential to run code, which is very different from a traditional Python context where just output is just printing text to the screen. There's no weird side effects, right? This is the ultimate side effect, right? Rich output in NB Viewer. So all the rich output formats that I've described here work on NB Viewer. And one thing that is important is the JavaScript environment that this code is run in. The live notebook has jQuery loaded, and we're also using require.js in certain contexts. And on NB Viewer, we're making sure that those libraries are also loaded. So for example, if you have output like I have had up above here that uses jQuery's getScript function, if you run that on NB Viewer, jQuery's getScript is also available. And require.js is also available, so you can use require to load other JavaScript as well. That's a little bit more advanced material, but I at least want you to know that exists, and that for the most part, rich output just works on NB Viewer as you would expect. All right. Do we have scheduled breaks, does anyone know, or can we take breaks whenever we want? What's that?
I don't know, but I was just saying, go ahead.
You know what?
You can take them whenever you want.
Let's take
We nominate.
a very short break, maybe a 5-minute break. Get up, get some coffee, stretch. They're not pre-scheduled? All right, let's take a short break. I'm going to start talking when that clock up there says 9:20. So how do you think we're doing time? So I have the exercises for the rich output, and then I have customization and exercises for customization. So I still have quite a bit.
No, I think we're perfect.
Okay. All right.
Hey.
Hi.
So security models for
Hello? All right, we're back live. Let's go ahead and get started. So, to us, the most important thing about this tutorial is that you leave here able to use these things yourself. Right? And so we want to spend some time allowing you to play with them. We have some more exercises. Again, we really want you to just spend time playing around with this, trying to code, trying to use these objects. And the tutorial will become more and more difficult. By the end of it, I would guess not everyone will be able to follow along. We're trying to sort of gradually increase the difficulty. I think at this point, with the rich output, most of you should be able to follow along with these examples. So here's some examples. We'll give you some time to work on these. And yes, I am in the name of the notebook that you can't see. So it's Rich Output Exercises. Yeah.
What's the hierarchy of folders or whatever where that lives?
So if you can find this file here, so it's IPython in-depth index interactive widgets. It has a link to that notebook down here in this section. That's the easiest way of getting to it. So if you want to see what this repository looks like here, so here's the IPython in-depth directory. The main index that has links to all the notebooks we're using is this file here, index interactive widgets. The actual notebooks that we're going through are either in the examples subdirectory or in the exercises subdirectory. But again, don't worry about where the notebooks are actually located. Just go visit them in this file here. And this one that we're working on currently is Rich Output Exercises. So the first one is this. Just create a new notebook, and then try using the following display classes in the notebook. Here are the import statements that you'll need. And so find an image on the internet and display it in the notebook using the image class. You can either save the image in the notebook's directory and use the file name keyword argument, or you can load it using the URL keyword argument. Next would be to find a snippet of HTML on the web somewhere, and then use the HTML class or the $HTML magic to display that. Then do the same thing for JavaScript. And as you go through this, try displaying these objects both by returning them from an expression and by using the display function. And added bonus points if you can figure out how to do call display in a loop and change the representation each time. So we'll give a few good minutes for you to work on this. And we'll give you more time to work on this, but I'm just curious, what types of pitfalls are people running into as they use these, just so everyone can learn from each other in terms of what you run into when you try? Yeah?
HTML text in the HTML expression, how do you encapsulate it so it doesn't straight parse it?
How do you encapsulate it so it doesn't, so what doesn't try to parse it?
So the symbols in the HTML content are not interpreted outside of this. I'm writing HTML, trying to use HTML text, a lot of HTML text.
Yep.
That's correct.
Yes. You may have to use a raw Python string. If there's, so that might be, at least there's some characters there that need to be escaped.
Of course, it's handled with a string.
But no, you should be able to pass it directly. Like, you don't have to assign it to a variable. Other questions that people are stumbling blocks that people are really. So the image object actually has keyword arguments for that, right? It has a width and a height in pixels that you can specify. Not all of our display objects have. I don't think we expose every possible function for all of these things, but I think the image object does have a width and a height. Maybe you could just confirm that and try it. Let us know. All right, so we have a fantastic question here. I was hoping someone would get to this. And why don't you just state your question out loud for everyone? Or actually, here, let me, I think.
So I was trying to display multiple images where each image is stored in a list. You loop through and then you sleep and then you redisplay the next item. And they display them one after another sequentially. And the question was, rather than having 15 images at the end of the list, how do you overwrite each of them so it's more like a slideshow?
Does anyone know the answer to this? I do, but I want to see.
Is it clear output?
Yes, it's clear output. So we have a function, IPython.display.clearOutput, and if you call that at any point in your cell, it will clear the output, the current output state of that cell, right? And so you can use clear output to perform animations. Lowercase here, I'll actually type it and do a small example here. Yeah, so here's a simple a working example of clear output. So I'm displaying a simple HTML counter here in a loop, time.sleep in between, and clear output. And in general, you usually want to do wait equals true. What wait equals true means is that the actual clearing of the output in that cell shouldn't happen until right before the next output is about to be displayed, right? And so this is basically a sort of a way of doing, frame swapping. If you say wait equals false, then it will actually clear the output immediately, even if the next output is not going to arrive for a while, and oftentimes that will cause flickering. So usually we find that wait equals true, and actually I thought wait equals true was the default, but I was wrong. So yeah.
Will that clear the last
When I run it, so here's when I run it. That's
okay. So when I was doing it, because the clear output is at the end, it cleared the last display as well.
yeah, and so it obviously depends on how you order your display, sleep, and clear output calls. The exact sequence of that, I don't know. I wasn't thinking too much about the particular order of that, but yeah, you could put clear output first in the loop if you wanted. So there's two more exercises here. I view these as more optional, but I think they're really good exercises. The first one is to explore the idea of embedding content from another website that offers embedding capabilities. So SoundCloud, if you haven't seen it, is a nice website that people use for sharing music. And so you could, here's a track, and if you click on a SoundCloud song under the share button here, there's an embed, and it will actually give you a string of HTML here that you can copy into an HTML display object in IPython, and you'll actually be able to get the SoundCloud embedded content in the notebook. So that's one example, or one exercise to use. And then the second is designed to get you to explore NBViewer. The idea is create a notebook, and actually, hopefully you've already created a notebook that has rich output. Upload that somewhere public on the internet. One of the best options would just be gist.github.com. And then after creating it, view the notebook on nbviewer.ipython.org. And the way this works is if you go to NBViewer's homepage, you can provide a gist ID. So when you create, let's see, here's my gists. And so when you create a gist, we'll go to this, you'll notice this ID right here is the gist ID. If you paste that here, it will render a static version of that notebook. So that's a fantastic thing to practice in terms of sharing notebooks with other people.
How do you get to the JavaScript of your notebook? Or the JSON?
Yeah, so how do you get to the JSON of your notebook? I think, so this is the full page. Obviously, this is not the raw JSON. So you can click on raw here.
I mean, so I want to put mine up there. I want to put mine on Git.
So how do you get to the JSON on your local system? I often just open it in a text editor, and I mean, there's no simple. Well, I should say, so Min has a notebook extension that actually provides a little user interface in the notebook that you can just single button click, and it will upload that notebook to Gist. So that's another option. What's that?
What adds that much?
Min, one of our developers. So yeah, it's a little unfair. If you ever watch Min use the notebook, you'll learn like, wait, where did you get that? My notebook doesn't have that. And it is. Yeah. And part of our philosophy is that we want IPython in the notebook to be very extensible and customizable, and we're encouraging the community to develop extensions for these tools, and that allows us to maintain a more conservative approach to development that moves a little more slowly and really focuses on core features. The difficulty with a project like IPython now is that it is massive. It is already too big, really, for any one person to keep inside their heads and manage. And so we're doing everything we can to actually scope limit the project. So that's why some of these extensions are not part of IPython itself. But it's also part of the great thing about the open source community is that they don't have to be in the project for them to be available on GitHub and other sites like that and usable by the community. And you can bug Min if you're interested in his extensions. But there's a lot of, it's not just Min, there's a lot of people who have extensions to the notebook. So another thing, yes? Yeah, so Fernando's comment is that the xclip utility on Linux allows you to quickly get a file into the clipboard. Another option is that I think it's a Ruby program, right, Min? There's a gist command line program that you can just do gist space, the name of your local file, and it's done. So that's another approach. So there's many different ways that you can go about this. Yeah, question or comment? You know, we've talked a lot about that, and there's been some informal efforts along those lines. I think our feeling right now is that for a language community where the idea of an extension is something extremely specific, right? An R package or a Python package is something that's very specific. You can install it in a consistent way. IPython extensions are not that way at all. Sometimes it's a CSS file. Sometimes it's JavaScript. Sometimes it's Python with CSS or Python with JavaScript. Or it's something that's designed, it's a formal IPython extension that's designed to work with our configuration system. And so and the installation of all of these different things looks very different. And so it's something we're continuing to think about. I think the other part of it is that we want to both distribute the code throughout the community, but we also want to distribute the management of the code through the community. And creating that centralized repository, it's just another thing for us to manage. And also it's you know, we're really wanting, we are embracing, and we're wanting the community to embrace the distributed nature of projects like Git and sites like GitHub, that, you know, it's not in any way required that it be in a central repository. That's a sort of, I mean,
Discovery, we have something as simple as just, you know, like a GitHub page that is, you can submit pull requests for Min, you can have a link to Min stuff, and then if I write something cool, I can submit a pull request and just
It- Yeah. Yeah. So that's sort of the layer that we're formally doing right now. I don't know, but I'm sure you can Google or browse our wiki site on GitHub for that. All right, so let's go ahead and move on. I think it's good to keep going. So the next section of content is focused around showing how you can add custom display logic to your own classes. So previously, I described the architecture of this display system, and then I showed you the built-in objects we have in IPython that already have this display logic attached to the object. And you may have your own objects, though, that you want to add this logic to. And so, again, here's a rough sketch of the different representations we have. And again, in Python, there's this _repr method that gets called to handle textual representations. We have a set of special methods that handle there's one special method for each representation. The general format is _repr_ the name of the representation and then a trailing underscore. You may think, well, why didn't you use sort of Python's notation of _? And if you read the Python documentation, they recommend that methods with those names be reserved more or less for the language itself. It doesn't prevent you from doing it, but because we were defining sort of a new spec, we didn't want to do something that could potentially conflict with the core language in the future. So let's begin by importing the display functions for the individual representations, and then this notebook will also use matplotlib. And what I'm showing here is the preferred way of importing matplotlib moving forward with the IPython notebook. Previously, ourselves and a lot of you were using %pylab inline, and we're encouraging people to move away from pylab. It causes more problems than it solves, mainly because it imports a lot of names from a lot of different places, and those names may conflict with names in your code, and they can even conflict. So for example, pylab inline imports a number of names, and if you then do from SciPy import star, SciPy also imports the same names, but they're different functions. And so you can quickly get into a situation with pylab where you're calling a function and you have no idea where that function comes from, and it's actually the wrong version of the function. And so we're really encouraging people to be more conscious of the namespaces that they're importing things from. This is sort of the canonical way of getting matplotlib and numpy imported and running with the inline backend for the notebook. So we'll run that. So here's a list of the special methods. So there's repr, HTML, JSON, JPEG, PNG, SVG, LaTeX, and then I've listed here what those methods need to return. So again, these are methods that you would need to define on your object, and it's up to you to decide what those methods, the specific content of those methods. What we require is that the format of that, the return values are fixed. So here, the HTML method needs to return HTML as a string. If you return an integer from that method, you're not going to see HTML. I'm hoping it will raise an exception. I think it will. And so let's actually just do an example here. And this is an object that is a Gaussian object. And so here, the constructor, the init method, takes a mean for that Gaussian, a standard deviation, and then a size. And we'll actually be sampling from this distribution. The size will determine the number of points in that sample. And so you can see in the init method, we actually use numpy random normal to sample that distribution, and then we store that numpy array that contains those samples in self.data. We store the mean, size, and standard deviation. And then we have this semi-private attribute _PNG data that initially is none. And then we have a method here called figure data, and you don't really need to worry about the details of this. This actually builds a matplotlib plot, and then in IPython core PyLab tools, we have a print figure object or print figure function. That print figure function takes a matplotlib figure and returns the raw data for that format. So it doesn't write to a file, it actually writes to an in-memory Python object. And so here we take the raw data, and then we close the plot, and then return the data. And then the most important part of this is the repr methods, right? And first we declare a PNG representation. We say, if we haven't computed the PNG data previously, call self.figureData and get the PNG format. And then this simply returns the PNG data, right? So that's the raw bytes of the PNG data that we're going to return. And just declaring this method is enough to tell IPython that if you ever try to display this object, compute that data, bring it back to the browser and display it. We also want to have a LaTeX representation. And so here we're going to simply put a formula. Well, it's not exactly a formula, but it's a simple LaTeX expression that summarizes that Gaussian distribution. So let's run that code, create one of these Gaussians, and display it. Right? And notice which representation shows up here. Right? It's the LaTeX representation. I don't know if you remember in one of the previous notebooks, I give you a rough list of the ordering of representations. And actually, let me write that down here. So it starts with JavaScript, then HTML. I think SVG is there. So this is the rough ordering of things. I can't remember exactly where PDF appears in there, but notice that LaTeX is higher than the image representations. And so it's not obvious here, but when we return that object from this expression, we actually also computed the PNG representation, but the LaTeX representation we consider to be a richer representation, so we display that. We can also pass that object to display. And if we want to see the PNG representation, we can call display PNG, and we're going to see that, right? So questions about the basics of defining these special methods. All right, so here's a second Gaussian with different parameters. And then in a single cell, we could actually call display PNG twice, and we're going to see the PNG representations of both of those objects. This approach works well if you are, yes?
So you had mentioned whenever you call display, it renders on the server side of the page, it renders all versions and sends them all back.
Yes, yeah.
Does it do that every time? So if I call display twice on the same object, is there any caching that happens, or is it always counted?
So the question is, if I call display twice for a single Python object, do we compute all representations of those objects both times you call display, or is there caching involved? There's no caching involved. We do recompute those. And I think the difficulty there is we'd need the ability to compute a hash on the object to see if it had changed, and that we don't want to get into that. So we just compute it every time. Yeah, another question.
I'm curious about this helper function print figure, which seems like it should be a functionality part of PyLab itself. Is there some way in that direction?
We're not actively working. So the question was, this print figure function seems like it would be reasonable to have in matplotlib. I agree. Sounds like someone's got a pull request for the week. Yeah.
One other question on display. And is there any ability to do a bit of layout with display? Like if I wanted these two boxes to be displayed next to each other, or do I have to do that with a matplotlib like SciPy?
Yes and no. So the question is there an ability to do layout with display? And in the case you asked about, namely, you've got two Matplotlib figures if you want to display them side by side. I can't think of any easy way of doing that using display functionality. Obviously, you can use Matplotlib subplots. The general answer, though, is yes, in the sense that the notebook is just JavaScript, CSS, and HTML. You can publish arbitrary JavaScript, CSS, and HTML, and that CSS can completely restyle the notebook however you want. And so, for example, there's some CSS that a few people have been working with that actually shows sort of a two-column layout for the notebook with input on the left and output on the right. And you can do that with pure CSS. And so it's sort of the type of thing that it's not easy to do, especially if you want to just do it for that cell. Where you can do more advanced layout is using widgets. So the widget is more like a full user interface library. There's containers. The containers can be nested. They can be, distributed across rows or columns, and we will talk about that. So that's the more general approach for this, I think. Yeah.
A related question, which you may be going to get to, one way to do that, would be, I was curious, does the print figure work nicely for then embedding like an image tag into an HTML representation? If I want to,
Yeah.
I'm going to be trying to write, some of my objects are an image with some extra metadata. I want to be able to do a image plus the metadata below it.
Yeah, so another approach, this is a fantastic point. So if you can compute the raw binary data for your image, you can write by hand the HTML, or programmatically, write the HTML that builds whatever DOM structure you want. So you could put two image tags that are in divs that are next to each other, and the image data can be embedded in the image tags using these data URIs. You basically base 64 encode the image data and put it in the HTML tag itself. So you could do things like that as well.
And does print figure automate that for you? Can I just take the print figure that we just computed there and include that instead of the data URI in the image tag?
You would need to base 64 encode it.
So it does not automatically.
Yeah, it is the raw PNG data. Yeah.
But it's just one more.
Yeah, that's. So this works great if you are the author of the objects that you want to add the rich display logic to. There's many times, though, where you're using libraries, maybe it's NumPy or SciPy, and you're not the author of that object, but you still want to have rich display logic. And so we also allow that by allowing you to register display functions for objects in a number of different ways. So I want to walk through an example that shows how that works. So here's a NumPy polynomial class. You can see the built-in representation of that polynomial looks something like this. And we have a function here, poly to LaTeX, that is able to compute a LaTeX representation of that polynomial that is appropriate. So let's actually just call poly to LaTeX on our polynomial. We see that this returns a string representation of that polynomial object, where that string is LaTeX, right? So what we want to do now is register this function with our display architecture for that particular class. And let's look at how this works. So first of all, let's test this. So we'll just pass that to the LaTeX, built-in LaTeX Python or IPython object, and it does indeed produce a nice LaTeX representation. And the way we register that is using the IPython display formatters. And the way that we get a handle on these display formatters, we first need to call getIPython, which gives us the main IPython object that's active in the current kernel. And then that object has a display formatter attribute and a formatter's dictionary. And I want to show you what that dictionary looks like. So the keys in that dictionary are MIME types of the different display formats. The values in that dictionary are formatter objects. And those formatter objects have an API that you can use to register display functions. So here, I'm going to grab the LaTeX formatter. So we're doing IPython.displayFormatter.formatters text LaTeX. And then I'm going to display the doc string of the forType method of that formatter. So forType takes a type or class, and then it takes a function. And this is going to add a formatter function for a given class or type. The type can be a module name, a string, and then the function is a callable. There's also forType by name. ForType by name allows you to pass the name of the type as a string that can be imported. And in this case, we're going to use forType by name, and the call looks like this. So the first thing we need to pass to forType by name is the module where the class is located. The next, we pass the string name of the type. And then finally, the function that we want to use to display the LaTeX representation of that type. The reason it's convenient to pass these first two arguments as strings is this allows you to call this registration logic in a location and not have to import that class at the time. If you also already have it imported, you can use the forType method. ForType by name is useful if you haven't imported it or don't want to import it there. Let's call that. And once we have registered that function using forType by name, if we display that object, we instantly get the LaTeX representation, right? So this polynomial object does not have a repr LaTeX special method, right? It exists in NumPy, but we wrote this standalone function registered with the formatter, and the display architecture is able to call that function whenever that object is displayed. Here's a different polynomial, and you can see the representation obviously is different. There's a third way of managing display, and this is using the special method called _IPython_display_, or IPython display. And the idea of IPython display is this. It's a way of telling IPython's display machinery, don't do anything, I've got this, right? So this allows you to take full control over the display architecture and do whatever you want. A perfect example of this is if you have some sort of complex representation that requires multiple MIME types bundled together. An example would be if you have something that requires first putting up an HTML representation followed by a JavaScript representation that adds interactivity to that HTML representation, right? To do that, you would want to declare an IPython display method, and inside that call display your HTML representation and then display your JavaScript representation. We'll call the outer method a single time. Your code runs, and everything will happen. Here's a simple example of this. And this is Flot is a JavaScript plotting library. And here I have a Flot plot object that takes an array of x and y values and then declares an IPython display method. And notice what it does here is it displays some HTML that, again, all it really does is put a div, an HTML div on the page with a UUID. And then it displays some JavaScript that creates a Flot-based visualization in that div. And the important thing here is that this method can contain both of these calls, and we will call that a single time, and you'll see the results. Let's do this. There's a simple sine wave, and when you plot it, the plot gives that. Yes?
Why wouldn't that work with the display function? Why couldn't you display that?
So the question is, why is this special logic needed in this case? So you may be wondering, well, can I just declare a repr JavaScript and a repr HTML separately?
No, basically, if I did a rep HTML and did a display JavaScript in that rep HTML, that'd be the same thing.
So you're talking about embedding JavaScript in a script tag in your HTML.
I'll talk about
Okay, yeah. You can also do that. Yeah. Questions about this? We're going to dive into some exercises now. So the name of this notebook that has these exercises is Custom Display Logic Exercises. And so the first example the first exercise that we have here is something that I think all of you should be able to make it through. The second one is a little more advanced. But this first one, I really like this because it's simple. The example is that of a circle. And it really shows how you can define these special methods, and it is sufficient to get you started with adding this logic to your own classes. So here's the idea. We want to write a simple myCircle class. Here's a little skeleton. This skeleton is in a markdown cell. It's not in a code cell, so you have to retype that or copy it into your code cell. And the idea is that I want to have a class, circle class, that allows me to specify a center, a radius, and then a color, stores those as those attributes. And then I want to add special display methods for displaying that circle using HTML, SVG, LaTeX, and JavaScript. Right? So you need to define a special method for each of those, and then use the display HTML, display SVG, etc., to display those objects. So we'll leave this up and give you some time to work on this exercise. No, so it says here, so here's what the LaTeX string will have to be, \big circ, and you have to,
So, I mean, you're only, so it seems like you're only going to get one kind of circle.
oh yeah, no, obviously, yeah, it's really, really simple. Same with the HTML, actually. Yeah, I mean, it's, yeah, this exercise is not designed to actually create interesting circles. It's more designed to just show you how to write these methods and return something that gets something on the screen. All right, so how many people have been able to get at least one of these special methods working? Okay, that's pretty good. So I'm going to keep moving on. We have a lot of additional content to cover, and I want to make sure that we leave a lot of time for the widgets. If you have other questions about some of the other exercises that we have, there's another exercise below here for the custom display format, actually another 2 exercises that are pretty interesting. We encourage you to work on those, come bug us with questions. We'll be here through the rest of the tutorials, conference, and the sprints. And so let's move on. The next topic will be getting into the widgets. And I'm going to start out covering the high-level API for widgets, which we call Interact. And then John is going to come up and talk about the lower-level actual widget objects, the widget architecture, and then how to build your own custom widgets. And so again, the main distinction between widgets and rich output is that in general, rich output is a one-way communication of data from the kernel to the front end, which is displayed. It can be interactive because of the ability to do JavaScript in that context, whereas widgets involve a two-way communication between the front end and the back end that can be event-driven in response to a user clicking on buttons, sliding sliders, and so on. So let's have a look at this. So it is important that as of IPython 2.0, as I mentioned before, widgets will not show up in NBViewer. And for 2.0, even if you open a notebook on your local system, you will have to rerun a cell to see the widget again. In IPython 3, we're changing some of that. So let's look at Interact. At the most basic level, Interact auto-generates a user interface in the notebook that allows you to explore a function for different values of its arguments. And to show you how this works, let's define the simplest possible function we could, namely f of x that just prints x, right? And if I pass that function to Interact and add, the function will be the first argument to Interact. It's a positional argument. And the second argument is going to be x equals 10. And it's important that the x here matches the name of the argument in the function, where it's basically treated as a keyword argument to that function. And when I run that, Interact automatically produces a slider, and the current value of that slider is 10. And if I grab that slider and move it around, you can notice what's happening here. If you look right here, that is the output of that function. And every time there's a slider change event that's fired by my dragging this around, we automatically call that function, right? And another thing that's important to note here is that there's some sort of interpretation layer that's going on inside the interact function that it knows that the integer 10 should be interpreted as and represented as a slider. Right? And I'll talk more about how we do that interpretation shortly. We could also, however, pass a Boolean, right? So here I'm taking the same exact function, passing a Boolean instead, and in that case, the user interface element that gets generated is a checkbox. And you can start to see the pattern, hopefully, right? That we're looking at the argument that's passed to interact and try to infer what the appropriate user interface element is for that type, right? And so when I click that checkbox, we call the function. You can try to guess. Yes?
So does the interact actually return something? Do you have a semicolon after the
It does, yes. Let's run it without the semicolon. And it returns its string representation, right? Usually you don't, I mean, it's just sort of unnecessary. Now, you may think, well, couldn't we have built interact in a way that didn't return? I mean, this is odd, right? I have called a function, right? Here, let's think about this carefully. I just called a function, and it returned a function. In Python, what do we call a function that returns a function? The decorator. And the reason we did that, and I'll show this shortly, is that so interact can also be used as a decorator. Right? So it's a single interface that you can call as a standalone function or as a decorator, and that's why the semicolon is, we usually use it when we're calling it as a regular function. Can anyone guess what type of user interface element will be created if I pass interact a string for a keyword argument? A text box, right? So we do this, and indeed we get a text box, and as I type in the text box, the function is called. We display the output. So here is what interact looks like as a decorator. So in this case, I have a function g of x comma y that, again, just prints x and y. And ampersand interact, and then we can pass it the keyword arguments for x and y. X is going to be interpreted as a Boolean, y as a slider, and again, we get the expected user for interface elements, and that function is called. So this allows some flexibility in terms of when you define the functions and when you sort of enhance the functions with the interact capability. There's a flexibility in terms of when you do that. Yes? No, yeah, how do you, so the question is, how do you remove a widget from a cell? You can't do it programmatically currently. There's a little gray box here, and if you click that, they go away. But not programmatically, yeah. Yeah, and so I should note, actually, so this is the JavaScript debugger console in Chrome. And one thing that's important here is that even though widgets and output look like they're in the same place in the notebook document, they are in separate areas, and they are managed by more or less completely independent parts of the JavaScript code base. So here's the output sub-area, and then here is the widget sub-area, and they are not children of one another. They're sort of side by side, and that's sort of maybe more than you wanted to know, but yeah. So there are times that you want to call interact and not change one of the arguments of the function. A classic example of this is if you wanted to maybe write a function that visualized a massive pandas data frame, right? And so the first argument to your function is going to be that data frame. There's not some slider widget you want for it. You just want to pass in a data frame and have a UI for that data frame. And so the way that you can do that is using the fixed function. And so here's a function h of p and q. And here I'm saying I want to interact with h, For P, I want a slider that defaults to a value of 5. For Q, I just want it to be the number 20, always, right? So this would be where you pass in the pandas data frame. When the UI gets created for that, there's no slider or representation for Q. And notice when the function gets called, Q is always fixed at 20, right? And I think it's important to show you where fixed is imported from. It's ipython.html.widgets. Both interact and fixed are in that. Interactive, which I'll cover in a second, is also from that location. So widget abbreviations. When you pass an integer valued keyword argument, such as x equals 10 to interact, interact generates an integer valued slider control with a range of -10 to +3 times 10. So the minus the value to +3 times the value is our default range of the slider. And we consider 10 to be an abbreviation for that widget. You can also create an actual slider widget. We have Python objects that represent all of these widgets. So here would be the Python code for creating that slider widget by hand. You can actually construct and pass widget objects to interact as well. So if you want more flexibility in using interact, in setting the default values of the widget, you can do that. So here I'm doing interact, and instead of saying x equals 10, which is a widget abbreviation, I'm saying I'm just going to pass the actual widget object I want to use for that variable in. And you see that you get the same exact result, right? So this clarifies how interact works internally. When it gets a keyword argument that is a widget, if that widget has a value attribute, it uses that widget for that particular argument of the function. Otherwise, that keyword argument is treated as a widget abbreviation. And here's a table that summarizes how these widget abbreviations work. So true or false is a checkbox widget. A string is a text area widget. If it's a value, a 2-tuple or a 3-tuple of integers, you get an integer valued an int slider widget. If you pass the same arguments, but they are floats, you get a floating point valued slider, a float slider widget. And then if you pass a tuple of strings or a dictionary, you get a drop-down widget. And I'll show an example of that shortly. So let's look at some of these cases. So here is a 2-tuple of Python integers. This gives you a slider with that min and max value. So the min value here we expect to be 0. The max value we expect to be 4. If we provide a 3-tuple, so there's a third argument, they're all still integers, that sets the step size of the slider. So notice here, the steps are no longer 1, they're 2. It goes from 0 up to 8 in steps of 2. Yeah, so x is the name of the argument. This is the current value. Yeah. To get a floating point slider, you pass the same style of arguments and just make those floating point numbers. So here, let's.
In slider widget before, I changed only the step size to be float, and we left it all as
Yeah, I don't remember the exact logic we use, but we can try it out here, right? So here's 0 to 10, and if we change the 10, so that's clearly a floating point slider. If we change this to 10, it's still a floating point slider. So I'd have to look at the code to see sort of how we reason about that. Yeah. So you can also set the step size for floating point widgets or sliders as well. So here we're changing it to 0.01. You can see here the default is 0.1. So that allows, yes?
What happens when you have a slider? When you make the slide change to, say, integer values, and maybe you're sitting at 5 and you go to 6?
So yeah, the question is, what if your function takes a longer amount of time to run, right? What is the behavior? And we can show some examples, but the basic idea is that the user interface element, you can continue to slide. It's not like it locks up at that point. So you could keep sliding it around. And each time that user interface element changes, that triggers an event in JavaScript. And we actually throttle those events as they're being sent to the Python kernel. So as you slide a slider across, there can be 100 events that are triggered. And if your function takes 20 seconds to compute, that is a lot of time. The JavaScript code actually tracks, and when there are 3 outstanding requests to Python, we start to buffer those in the front end and wait till the kernel has finished computing one of those, and then send the next one. And so it's not fantastic, but it does remain fairly responsive. The most important thing is that these user interface elements in the web browser, every time they change, they do trigger Python code to run, and that Python code can take anywhere from a millisecond to weeks. And there's nothing we can do in our widget framework to hide the fact that that function takes a lot of time. One thing that we have a pull request that's open right now for IPython is to change how, provide an alternate mode for Interact that allows you to position all of your user interface elements and then click a go button that runs the function at that point. So that is something that we're thinking about and trying to address, because it is, you quickly run into this.
It seems like in many cases, if the user moves it, what I'd actually want to do is discard whatever running calculation and use the current value. Because the user really is going to want to see whatever they've set it to.
So if you play around with the throttling, it ends up basically working that way. So if you drag it across and there's 100 events that are fired, what happens is the first 3 events will be submitted, and while those work, we buffer all intermediate events, and then we'll submit the last one.
You'd rather not have 3 if it's 20 seconds.
So you can configure the integer that we're using there for the throttling. Yeah, 3. I mean, maybe it should be 2. Maybe it should be 1. It sort of depends.
The context in which that pull request was made would be, for example, where you have a multi-parametric equation with a complicated visualization. You want to set all the values.
Yeah.
And then say,
Yeah.
heat render rate.
Exactly.
I would like for coffee.
Absolutely. Yeah, that's exactly the usage case.
Brian, just to clarify.
Yes.
Let's say I have a job that runs for 15 minutes.
Yep.
Okay. When I start dragging the slider, as soon as that slider takes on a new value, it's going to kick off that 15-minute job.
Yep.
And it's going to kick it off at that value that slider moves.
Correct.
If you've got a really high resolution slider, like if you move from 1 to 1.1, the job is kicked off.
Yep.
And you're not going to get, let's say you're dragging for 2, you're not going to get the results for 2 until 15 minutes have gone by, and then 1.1 results come back, and then 2 will kick off.
So basically, with the way it works right now, it takes 15 minutes, and you move it more than 1 tick. It will take at least half an hour to get. It will probably take exactly half an hour.
Yeah.
3 days, like sweeping through all that stuff.
Yeah.
And one job per increment of interval.
Yeah.
I think that the short answer is, for now, you shouldn't tie Interact to a callback that takes more than 30 seconds. Because that seems unreasonable.
It depends on your patience level. I mean, honestly,
I don't tie callbacks as much as 30 seconds.
yeah. I mean,
You shouldn't interact with things that don't operate as non-interactive types.
yeah. All right, we got a lot.
There's another option, which is that instead of dragging the thing, it looks as though you can position the mouse and click, and it jumps to that spot. So instead of dragging, you can just move over, click, and hop to that spot without triggering a calculation for all the places in between.
Yeah. So
If I guess your eyesight's really good and you can calculate
The challenge is if you have an hour-long function and you want to position 10 sliders and checkboxes and then press go once. And that's a usage case we absolutely want to address. So one thing I would encourage, if you're curious, write a function that does time.sleep something and then prints something, right? And play around with it and actually make the sleep interval a slider itself. And you can play around with how responsive it is for the different delays. Yeah?
Is it a way mathematically just record this to go through and then if you kill them all?
No. So the question was, is there a way to programmatically access the list of outstanding widget event function calls and clear that queue, and there's not currently.
One last question.
Yes?
When you interact with the three people, is that essentially the same as using that more
In slider widget? Yes. Yeah, we have a translation layer that converts those abbreviations to those widgets inside of Interact.
If you mix up integers and floats?
Yeah, I don't remember the exact details of that logic in the code, sort of how we handle mixtures of floats and ints. I always just be consistent, and specific.
Sorry,
Yeah.
how do we get the output of the function after that? Is it possible to do that? We want to get the output.
Yes, I'll cover that in just a second. So if I pass a tuple of strings, I get a dropdown, right? Now, the important thing here is that the user interface dropdown here is built of those strings, and the values in Python are also those strings. There may be times where you want a drop-down menu, but the Python values you want are maybe Python functions. They can't be serialized and brought back to JavaScript. So you need a way to have sort of separate display names from the Python objects. That's what the dictionary is for. So here, I've got the string 1 and the string 2, and the Python values 10 and 20. So the 1 and the 2 are used for the drop-down elements, but the actual values in Python are the 10 and 20. Right? So you could have a drop-down menu where the functions are different algorithms, different functions.
Are they, the question of the ordering of the values in the drop-down, are they ordered that way because it's dictionary? You never know.
I think it's just alphabetized.
Yeah, and that's a bug, an outstanding bug. I need to address.
Yeah.
Well, it gets weird because we have to convert it to JSON and then send it to the browser.
JSON doesn't have an ordered
then
type.
the order's gone.
Yeah. But that is something that we want to fix.
It's on my issue list.
So, a couple of us here have noticed when we ran the widget slider thing, now we can't run more cells. Or sorry, when we ran the drop-down combo box, it's not letting us run more cells.
Why don't, John, you can go look at that. That's weird. It shouldn't do that. Well, that's our next feature we'd like to talk about. Isn't it cool? So I'm going to fly through this content. We still have a lot. I want to make sure there's time for John to go into more details on the underlying widget objects and the widget architecture. Two other points in this notebook. So if you're using Python 3 supports function annotations. This notation looks as follows. So there's the argument, or the name of the function argument, colon, and then you can provide an annotation. In this case, I'm providing a widget abbreviation in this context. And so if I were to, I'm not running Python 3 here, but to find the function using this, then I can just call interactf, and I don't, at this point, have to provide any widget abbreviation information. And so if you're using Python 3, this allows you to build the widget interact metadata into the function itself, so you can just call interact at any time, and it's built in. We do have an annotate compatibility layer for, it's a decorator for Python 2 that gives you the same functionality. So here I'm annotating that function and saying X has an annotation of true, and then I can just call interact of F without specifying a keyword argument to interact at that point. To answer the question up here about can you get a handle on the last value of interact, or sort of the current value, and that is done by a companion function to interact called interactive. Interactive returns the widget that's created by that interact and doesn't display it immediately. There's two reasons you might want to do this. One is to get these return values. The other is that this can allow you to embed that widget inside of other widgets in a more complicated user interface. John will talk more about that. So if I look at the type of that return object, I can see it's a container widget. It has children. If I display it, I see what you would expect, the actual widget for that. And then there's two important attributes. One is keyword args. The keyword args contains the current keyword args that the user interface is correlated to. So here, notice it's 2 and 20. If I change these two sliders around and re-access keyword args, I see the current value. And it also has a result attribute that is the result of calling that function for those attributes. So that's, that. All right, any other questions about basic interact functionality? So we have a notebook here of exercises for interact, and we're running short on time, and so I'm not going to actually give you any time here to work on this. If you're interested in this, I highly encourage you to spend time over this week looking at this, bugging any of the IPython devs. And actually, I should introduce more of the IPython folks that are here. So there's Min here. Fernando is in back. Kyle Kelly is next to him. John is obviously here. Is Thomas here? Okay, Thomas is in HDN5. Aaron, who's next to Min, also knows a lot about IPython, so feel free to bug him. And then Thomas is also here this week. Matthias is also here this week. And so we will be around basically all the week, including the sprints. So feel free to come and bug us. Before John starts to cover the widgets in more depth, let's take another about a 7-minute break. Eric? Or didn't we use IPython display? Yeah. So the way the widget display is triggered is using this _IPython _display method. That's how we do it internally, and so it does use that same display architecture to get it on the page. But we can talk more about sort of the technical details about how all that happens. Yes?
What was the solution to turning the...
Just refresh the page for now. I'm going to open an issue. Just refresh the page. You don't have to restart the kernel, just the page.
Yeah.
Is it possible to create a widget out of a class method?
To interact with a class method?
Yes.
So...
I mean, the use case that I had in mind is, well, maybe it's obvious.
Well, so I have some code in a separate project that does that, and I haven't submitted a pull request to IPython, so I can show you where it is afterwards if you want. Okay. Yeah. All right. Well, one more.
Is there a
Push button, like a button widget. Yep, absolutely. John will cover that. The challenge with the push button widget is that it's event-based, not state-based, so it doesn't have a value, and so it can't be used with interact. But you can still, I mean, we'll show you how to build. So the pull request that addresses this does use the button widget for this. So yeah, absolutely. Yeah.
How could you use all of this stuff to make something which doesn't show the rest of the IPython notebook and just kind of looks like an IPython?
Absolutely. So John and I visited Aaron and Chris Keys, I don't know, a month ago, and one of the main goals there was that they were using the widgets to present the results of a computation to a non-technical audience, where they basically just wanted widgets on the screen. And John wrote some code that basically automates that process. So we can talk to you about that. So we feel like we have a good handle on the security of rich output. The security of widgets adds a whole new layer, and that's something that it's an ongoing process. And not yet. Yeah, let's break. I want to make sure we take a break, maybe 6-7 minutes, and then we'll get going again.
So do you have the code handy where you could show me where it is, or
yeah,
maybe we could do it later too? I mean, this is just a use case. I imagine, I teach a course on computational methods for economists, and we have, class object mapped to a certain economic model with some parameters, and then there's a method that will generate a visualization, and you would like to be able to have students toggle the parameters.
So it's right here. So it's a mixing class.
Okay.
It defines an interact method that you can attach to classes.
I see. Okay. Okay.
And so it's I mean, and actually, as I was designing this, let me turn this off. All right, let's go ahead and get started again.
All right, so what are widgets? Widgets are things that exist both in the kernel and the front end. So here I'm using the same picture as earlier. What can they be used for? You can use widgets to create interactive GUIs, or just simply synchronize stateful or stateless information between the front end and the back end. So to use the widgets, you need to import the namespace, which is IPython html.widgets. It's the same namespace that Interact uses. I did. Oh, sound. So widgets have a wrapper, which we were talking about earlier. So you can just construct a widget, and if it's the last thing in a cell, it will be displayed. So here I construct an int slider widget, and then you see it displays right there. You can also display widgets using the display framework. So you can construct a widget and then explicitly call display and pass the widget in. That will also display a widget. And you can display the same widget twice. And if you display the same widget twice, you'll note that the widgets remain in sync. So as I drag one of these sliders, everywhere else that the widget exists on the page also will change. But that doesn't update the output in all the other cells. Just the output of the cell that you're manipulating directly, that the widget is child to, that output will be updated. So why does displaying the same widget twice work? Well, the way widgets work is you have a widget defined in the back end. So in Python, you have this widget class. And in the front end, there's a model that represents this class. The model in the front end is just a mirror of the widget in the back end. And the values in the widget in the back end are synchronized automatically for you, back and forth between the front end and the back end. So if changes are made to the front end, those values propagate back into Python and vice versa. So when you display the same widget twice, you're creating multiple views of that model. It's kind of like an MVC architecture. And this is actually backbone.js that does this for us, that manages the MVC type design. So you can close widgets by, if you have a handle to your widget, you just call .close, and that will hide the current widget, including its representation in other cells. But it doesn't close the widget area. You have to do that manually. Widgets all share a similar naming scheme. So we use .value for the value stored and managed by a widget. And this is important because Interact uses this .value key. When you're using Interact, it's getting and setting .value. So even if you create your own widgets, as long as the property that the widget, the main property is .value, it will work just plug and play with Interact. So you can set these properties and get these properties just like any other properties of Python classes. So here I've dragged the slider to 48, and I can look at the widget value. It's 48. And here I set it to 100, and you see that the widget actually updates to 100. Widgets have a list of keys, and these keys are the properties that get synced between the back end and the front end. You can query this list by calling .keys. And you see here there's, for the slider, there's things like min, max, some private things like CSS. We'll talk about that later. Value and readout, disabled, visible, etc. So there's shorthand for setting widget values. So instead of constructing a widget and then setting the value after you've constructed it, you can just pass the value in as a keyword arg into the constructor of the widget. So here I'm creating a text widget, and I set the value and disabled property in the constructor. And you see I get a disabled text box that says hello world. So one thing that a lot of people want to do is they want to be able to display one value multiple different ways. And the way that the widget framework is set up, there's only one view type, one visual representation of a widget in the front end. So if you want to display a value using multiple widgets, you actually need to link those widgets together. And you could either manually do that yourself and update the values of the other widgets as the value changes, or you can use this handy-dandy link function that we include in IPython to link widgets together. So here I import link. It's actually under a different namespace. It's part of our traitlet class. And I construct 3 different widgets, a float text widget, a slider, and a progress bar. And I display all 3 of them. And then I call link on the 3 widgets. And link accepts any number of positional args that have to be tuples. The tuple is the first argument is a handle to the widget. Second argument is the name of the key that you want to sync. So here I'm linking the value of A with the value of B with the value of C. And if I drag this slider, you see that the progress bar and the text box also update. And I can change the text box, but the progress bar is read-only, so I can't change it there. And if you need to unlink these for some reason, there is a .unlink with the returned from the link function. So then those are no longer linked. So I have a couple exercises set up for, or I guess a single exercise set up for that. See if you guys can display just a basic text widget and set its value and maybe play with some of the other properties of the text widget. Do like text widget, a dir of the text widget so you can see what exists, or text widget.keys. And I'll give you guys a couple minutes to do that, and then I'll show the solution. Yeah.
To get the widgets working? Yeah, how long will it take for that to be available? Well, the first step is just going to have them persist so they have visual representations, right? But the actual pre-computed outer product of like all possible widget states might be a little bit longer, maybe beyond IPython 3.0. But for 3.0, we'll at least have persistent representations of widgets. And that's a little bit, that's cooler than it sounds, because if you have like a custom widget that's some kind of 3D rendering that you can interact with, like manipulate, but not actually send state to the backend, you'll still be able to do that with just persistence, right? Okay, so it would behave just like the rich output. All right, I'm going to show you guys what I expected from this exercise. So here I import the entire widgets namespace just for convenience, and I import display. I construct an instance of the text widget and set its value to test, display that, and then query the widget's keys. And then this is what the output looks like. So you see there's a text box with some text and all the different keys of the text widget. Yeah. Yes, exactly. One, yes, it should. So if you set it to 1, it will still have the problem where it computes once, but then the next time you run it, it will run the merge of all the state messages sent, so the last state. I don't know. Try it. Tell me what happens when you set it to 0, or try a negative number. I don't know what would happen. It might not send any messages at all, I think. So moving on, I'm going to go over a list of some of the basic widgets that we include with IPython. This isn't all of the widgets, but it's just kind of standard GUI framework stuff. And I'm going to try not to spend too much time blabbing on about each individual widget. So you can get a list of the complete list of all the widgets that we provide by just looking at the widget namespace, and anything that ends with the capital W widget is a widget. So there are 8 numeric widgets that we provide with IPython. So some of them are floating point widgets, and some of them are integer widgets, half and half. Here I construct a float slider widget, so you can see some of the different properties that you can apply to this float slider widget. Float sliders and end sliders can also be displayed vertically. So if you set the orientation key to vertical, you get something like this, which could be useful for like an equalizer or any application like that. Yeah. The description cannot be LaTeX as of IPython 2.0, but in 3.0, you'll be able to have LaTeX descriptions. So if anybody has that problem. There's also a float progress widget, which you guys saw earlier. And it works the same way as the slider widget, the same property names. It doesn't accept input. It's just almost like a rich output kind of thing. Like it just displays output. There's also a bounded float text widget, so this works the same as the slider. It has a min and a max.
And then there's an unbounded float text widget that can accept any valid float. There are two different kinds of Boolean widgets. There's a toggle button widget and a checkbox widget. The toggle button widget just has a dark state when it's toggled on, and then standard checkbox. We provide 4 different types of selection widgets. Here's what the drop-down widget, which you guys already saw, looks like. You can query the value just through value, like normal. But the values list accepts, you can pass in a list of values that you want to represent in the selection widget. But you can also pass in a dictionary. If you pass in a dictionary, the value that the selection widget will display is the key. The keys in that dictionary. But the value that will be returned when you query it is the value of the key. So I have 2 selected here, but it actually returns numeric 2. If I have 3 selected here, it will return numeric 3, because that's what I've defined in my dictionary. No, not yet. I think in the PR where I add the description, LaTeX, you can also do it there. But I'm not sure. Maybe I did. There are the other 3 radio buttons. Select widget, which is like a list box, but it's called select in HTML, so we just want it to remain consistent with HTML. And toggle buttons, which is just like the single toggle button, but a group. There are 4 different string widgets that we provide with IPython. 2 of them accept input, and 2 of them are just read-only, kind of like rich output things. So there's the text widget, which you guys have seen, and a text area widget, which is a multi-line version of the text widget. There's a LaTeX widget, which allows you to display LaTeX, and then an HTML widget, which allows you to display HTML. Yeah, exactly, and you can display them in the widget area. So later when we get to parent-child relationships, you'll see that you can do all kinds of interesting things with them to build complex GUIs and have them floating around or whatever you may want.
Just a silly question. Can you create a text widget that contains the LaTeX code and a button that actually then displays it so that you kind of select that?
That's one of your exercises. You're jumping the gun. And then the last of the simple widgets is the button widget. So for your next exercises, in the same file that you were in earlier, I would like to see if you guys can create a selection widget. And it can be any one of the 4 selection widgets. And just try using the dictionary syntax to provide keys and then values. And if you're feeling adventurous, you can do something other than standard values. You could put in like a mutable value or something, and like class instances and stuff, and see if that actually returns correctly. Yes?
Is there any active work on a table widget and a tree widget?
Not officially. Yeah. I know Brian has been kind of mentoring some students, but I don't. You never got any of your students to work on a tree or a table, right? Like a spreadsheet or anything like that. No, yeah, not yet. Yeah.
Is there a cell widget?
A cell widget.
Yeah, a new cell.
Oh no, like you mean IPython prompt, like a IPython cell?
Yeah, an IPython cell.
Yeah, no, there isn't. But you could. I mean, you could hook up the text area widget to behave like that, but it wouldn't. I mean, it's not code mirror, so it's not going to highlight. Yeah, so no, not yet. But I don't think it would be too bad to do. I think you could do that. Yeah. A canvas widget. I mean, there's a D3. I've written a couple D3 widgets which use canvas, right, to draw the SVG. But no, not officially. If you want to open a PR, maybe there could be one. Yeah, I think I added them in, so I think in master they might, but I think you're right, they're missing from 2.0. I've gotten that complaint before. Okay, I think we'll move on to the next exercise. So for this next exercise, I'd like to see if you guys can use link to link a text area widget and a LaTeX or an HTML widget. So as you type in the text area widget, you should see LaTeX being rendered live, or HTML if you choose to link it with an HTML widget. Before we go, I'm just going to show you the solution to the selection problem. So here, I display a radio button widget and set the values to a dictionary, and then print the current value and set the value to 1, which is center. Yeah, I know, I'm sorry. I think doc strings are somewhere in there, but they're missing from the module level, right? Are they defined on the class? One or the other?
When I just do text area widget question mark and hit enter, it doesn't give me.
Poop. Sorry. If it isn't, it should be. Yeah.
Can I put links to a functions in that?
Yes. Yeah. But you mean link?
I wouldn't
So
put
use
dollars
link.
around whatever's in the text box into the.
Yeah. Yeah. So I mean, you can like link a text box to the min value of a slider. Is that what you're asking? Like to two different values, or you'll ask?
Instead of linking A to B, you want to link A to B. That's exactly right. So to process the linked value going one way. The problem is you have to have the input and have to because somebody might interact with the other one. Yeah. But I don't know.
Oh, yikes. You should be able to do it with CSS, which we'll get to the CSS in the maybe I should have done the CSS first. Off the top of my head, I'm not quite sure. You could try. Really? You can try doing dot set underscore CSS, and then in parentheses, the first argument would be in quotes width, and then comma, and then in quotes some pixel width, like 100 px or 200 px. Try that. That might do the trick. Yeah. Oh yeah, definitely. Just like a one-way thing, right? Yeah. Do you guys need more time or a little bit more time? Okay, I'm going to show the solution for this one. So here, importing the whole namespace again, importing display, but also importing the traitlet link function. I create my code widget, which is just a text area widget, so it doesn't have any syntax highlighting. And I create a preview widget, which is the LaTeX widget. And I display both of them and then link the value of the code widget to the value of the preview widget. If I run this, I get a working LaTeX editor that I can do all kinds of weird stuff in real time. Yeah?
Notice that it would be convenient if I could just do like code.value, preview.value, since in context it should know what those are. Is there a reason it needs to be the separate item string?
I think because it evaluates to a value, right? It's not a pointer if you pass in code.value. So like we need to know what. Yeah. You would use, I'll get to events here in the next section, and you would use a custom event, and it would be a one-way kind of thing, because the automatic linking only works for things that are, one-to-one. Okay, so on to events. So there are a couple different events with IPython. The button widget itself is a stateless thing, so the only reason it exists is to have these stateless messages, so just on-click events. And there's actually an on-click method that you can register a callback for when a button is clicked. And you can see it here. I create a button, display the button. I have a method on button clicked, which accepts the button instance, and it just prints button clicked. And if I do button.onClick and pass that handle in to that function, I get a button, and when I click it, it runs that piece of Python code that's inside that function. The same exists for the text widget. There's an onSubmit event, and you can register a callback for that. The onSubmit event accepts the same thing, the sender. And here I just print the value of the text box. So if I type something like hello world and click enter, enter triggers the submit event. The text doesn't get cleared because I'm not explicitly clearing it. If I did text.value equals that, then the text will be cleared as I click return. So then you can have like a command line kind of widget or something, like some kind of input processing widget. So the most common use of events are the traitlet events. And Brian talked about, I think he mentioned traitlets briefly, but traitlets are something that we use in IPython that are basically an easy way of creating properties. And our traitlet framework has a whole bunch of different helper methods that allow you to do all kinds of interesting things with these properties. And the widget framework relies heavily on the traitlet framework. The traitlets are what the widget framework listens to see if the values of the widgets are changing, and that's how it knows when it should be sending state to the front end. So you can actually use the same events that the widget framework uses to listen to the widget's properties. There's an onTrait change method of every widget. And here I've just printed out the doc string of the onTrait change. But there are 4 main signatures. One callback that just gets called anytime a trait has been changed. A callback that gets called with the trait name of the trait that has been changed. one with the trait name and the new value, and then one with the trait name, the old value, and the new value. And so when you declare your callback function, you can declare it with 0, 1, 2, or 3 positional args, and the traitlet machinery will actually inspect your function and then pass it different parameters depending on how much parameters your function accepts. So here I create an int slider widget, display the widget, and then I have an onValueChange method, which accepts a name and a value. So this will be the second, or the third callback here in this list. And the name and value don't actually matter. It could be, you can give it any arbitrary name. It's not looking at the argument names. It's just looking at the number of arguments. And here I print the value. So then I call int underscore range on trait change to register this handler for the int slider widget. And I pass in the callback, and I say that I only want to listen to the value trait. If I didn't provide this string here that says value, it would be called back for any trait that changed on that widget. This can also be a list, so you can pass in just a single value as a string or a list of values that you're interested in. So if I drag the slider, you see in real time, you can actually see the widget framework pushing these values to the back end, and then the back end printing out more values. And you can see how fast it is. It's really responsive. So I have 2 exercises for you guys. One, I just want to see if you guys can use the onSubmit method to register a callback for the text widget. So I'll give you guys a couple minutes to do that. Dot keys. So the keys we talked about earlier, that's just showing the traits. So I've got a lot more material I want to try and cover, so in the interest of time, I'm going to show you guys the solution to this. So here I just create a text widget, create a function to handle the submit of the text widget, and then in the submit, I print the value and then clear the value. And I call widget.onSubmit and pass in the handle of the function. And then instead of calling display explicitly on the widget, here I just return it, and the repr framework, the rich output framework, takes care of the rest. So here you can see it's working. So the next thing I want you guys to try to do is to use the onTrait change event. Just use that to register a callback that listens to the value of a text box. Okay, we're gonna move on. So the solution to this guy is to create a text widget. Then I have my callback, and I call onTrait change and pass in the callback, and then tell it that I want to listen to value. And if you notice, this behaves different than what we were doing before, where we were listening to the onSubmit event. Instead, this is executing in real time as the text box changes. So there's a lot of different things that you can do to style your widgets. I'm going to go through a lot of them, hopefully not too quick. But I don't know if we're going to have time for the exercises. I guess it depends. Show of hands, are people more interested in seeing custom widgets? Like writing your own custom widget? So like 2, 3. Versus styling widgets. Yeah, like coloring them, placing them in interesting places, and I mean, I'll just go through that really quick and then spend a little bit more time on the custom widget stuff if that's what everybody's interested in. Sounds like that's right. Okay. So because widgets are browser elements, you use browser styling to style widgets, which is cascading style sheets, CSS for short. There's a set CSS method that lets you set CSS properties of widgets and remove CSS properties. So you can use set CSS to do things like set the background color of widgets. So here I create a text widget and then set CSS background line, and then I get a text widget with a lime colored background. CSS also accepts color codes, RGB color codes. So the first byte is red, green, and then blue. And that's specified as a hexadecimal string. So here you can see I changed that to 0 red, 0 green, and 255 blue. And then my text box becomes blue. For color in CSS is just color. So it's not background color or for color, it's just color. Here I changed the text box's font color to white. You can also do things like set the size using CSS. And the set CSS method accepts dictionaries as well as a key value pair. So up here in the cells that I just showed you, I'm setting the key and then the value, separated by a comma, as positional arguments. But I can also pass in a dictionary of keys and values, so they'll all get set at once. So here I'm going to create a button, set the width to 100, the height to 100, and set the background of it to red. And you can see here's our 100 by 100 red button. To remove styling, you call the set CSS method again, but pass in an empty string. And this tells the browser that you're no longer interested in the style that you have applied to that item. So here on that button, I'm going to call background with a blank string. And then you see the button reverts to its standard bootstrap coloring. If you guys want more information, you can find CSS info online. Just search it in Google. The Mozilla Developer Network has a really good set of articles on cascading style sheets. And anything that you find there, you can apply to your widgets. So some widgets have a notion of parent-child relationships. As of IPython 2.0, you can only have one instance of any particular child in a parent. So you can't have parent widget A and then 2 B childs. That limitation will be removed in IPython 3.0. So here I'm going to create a container widget, which is our basic widget for grouping multiple widgets together. And I'm going to insert a float range widget and a string widget into the container widget. And then I'm going to set a red dotted border so you can see the container widget. So here you can see those two widgets placed inside the container widget. And they are not linked or anything like that. They're just grouped together. And this is important because later you can child this widget to more complex widgets like pop-out widgets and things like that. So you can either specify children in the constructor as you're constructing the widget. So here for this container widget, I pass in the children as a list. And then when I display the widget, it automatically displays the children as well. But you can also add children to a widget after the widget has been displayed. And if you do that, the second that you add the children to the child list, the children will be displayed. So here you can see that I create a container widget, I set the dotted border again, and then I display the container. And then after I've displayed the container, I create an int range widget and set the children property. And you can see the int range widget gets added to the container widget. There are a couple of special containers that allow you to display multiple groups of widgets together. We provide the accordion widget and the tab widget. These are Bootstrap 3 controls. I will show you those. So here's what the accordion widget looks like. It's just a collapsing and expanding type of thing. And then here's what the tab widget looks like. It's just a standard tab control. These widgets, except they have a child list, and each child of these special widgets gets its own page. So in this case, where I have, it looks like I have two widgets per page. What I'm actually doing here is creating this tab widget and then passing in a container widget as a child that has two widgets. So it's three levels of children there. We also provide a special pop-up widget that allows you to pop your widgets outside of the DOM. So now your widgets aren't actually displayed within the standard widget area. And this is useful because you can have these widgets floating as you're running through your document, and you don't have to keep scrolling back up to look at the output as you're interacting with it. So here you see as I run down this notebook, that pop-up is staying in one place. When I get to the bottom, I increase the counter once again, and you see it does indeed update. And then I can close the pop-up using close. But a couple things I want to mention about the pop-up. You can also, it snaps to like corners of the document. It's resizable. This I don't have sizing right now. I don't have the appropriate CSS set to size this text box to the parent. But you can also dock it. So if you want it to be inside the widget area, you can do so. And then you can close it and reopen it using the button. But you can also programmatically close it using the .close method of the pop-up widget. So if I call .close, it goes away. There are a couple different ways that you can align widgets. There is a default alignment provided. Most widgets have a description property. When you set the description property, it creates a little label to the left of the widget. The label is always right aligned, and the widgets are always left aligned. This is the same property that Interact uses to set the labels of the different widgets it creates. If the label is too long, the widget gets shifted to the right. And if a description is not set, no label exists. So you can see this text box doesn't have a label, and so it doesn't get aligned with the other widgets. In the browser, there's a notion of DOM classes. These classes allow you to group CSS properties together and apply them in batch, 2 different elements. We provide an add class and remove class method in IPython with the widget framework. These methods are path dependent because they allow you to use selectors to add and remove classes based on what classes are already applied to widgets. So here I have the same code, and I'm going to run it in 3 different orders, and you see it produces 3 different outputs. So you have to be careful when you're using add and remove class that you know what order you're going to be using them. And that's one of the reasons why add and remove class only work after your widget has been displayed. Because we can't cache that, because there would be some people who would probably use add and remove class to create like a blinking text box or something, and that would grow in the memory order n, and we wouldn't want to do that. So we also provide a couple of alignment classes, and these alignment classes are actually browser specific. It's part of the flexible box model. By default, things in the notebook, widgets in the notebook, are aligned with the vertical box. So your widgets will look like this. But you can also use an hbox class by removing the vbox class and adding the hbox class to display your widgets horizontally. There's also a packing, which allows you to specify where the widgets will appear on the axis that they are displayed on. So if I specify a packing start, the widgets are left aligned. A packing center, they're aligned in the middle. And a packing end, they're aligned on the right. There's also align classes, which allow you to do the same thing, but on the axis that's perpendicular to which the widgets are displayed. Last of the Flexbox classes are the actual Flex classes, which allow you to specify fluid layouts that adjust with the size of the document. And the Flex number is what specifies how greedy a widget is for space. So you can provide these box-flex classes to your widgets and change how greedy they are. Box-flex 0 is the default, which means it's not going to try to resize to the document at all. So here I have a couple different examples of how these behave. If you have like two boxes with flex 1, they divide the space equally. If you have a box flex 2, it will try to take twice the space of the flex 1s. So here's an example of how this can be applied to widgets. So here's a group of button widgets that I've just displayed in order. What I can do is display those widgets inside a container, remove the vbox class, and then add an hbox class, and then those buttons get displayed horizontally. I can then adjust some properties to center them by setting the width to 100% and centering that, or I could have used the Flexbox classes that I described above. There are a bunch of style classes provided with the Bootstrap framework that we use. So you can color your buttons. There's all these that you see here. There are different classes provided for containers, so you can create different kinds of alerts. There are different classes provided for the progress bars. You can even have little animations. And we also provide a visible property that allows you to hide and display widgets in place. So here I'm hiding and displaying the hello world string widget. And this could be useful for hiding and displaying like a container with multiple things for a forum. Okay. Sorry, that was really fast, but I'll try to go a little bit slower now. We're on the custom widget stuff. We've got 5 minutes until the hour. I don't know how long I'm allowed to run over, or if anybody wants me to run over. I mean, I can shut up too. Okay, yeah, and I can also, if anybody's really interested, I'd be willing to like help walk them through this after the class or at another time. So, building a custom widget. This is a diagram of what the widget framework looks like, or like where it sits in the stack of frameworks that we have in the notebook. So Interact is built on top of widgets. Widgets are built on top of the COM framework, and the COM framework is built on top of WebSockets and ZeroMQ. The COM framework is just an easy way to send and receive JSON messages to and from the front end and back end. So the first thing that I'm going to show you guys how to do, and this is supposed to be an exercise that you guys just kind of go along with me as I do it. I might not give enough time in between breaks just because we only have 10 minutes left. So the first thing I'm going to show you guys how to do is create a simple Hello World widget, and it's not going to be anything too exciting. We're just going to get some data on the page just so we know that we can actually use the widget framework. So there are two base classes. There's a DOM widget class and then a widget class. It's important to know the difference between these two. The DOM widget class is designed for any widget that you want to display in the browser directly in the web document, directly in the notebook, like inside that widget area. The DOM widget inherits from the widget, and the widget is a lower level representation that doesn't have any knowledge of like set CSS, adding and removing classes, any of that web browser specific stuff. So the first thing we'll do is import the widget namespace and then import a Unicode traitlet. By declaring a hello widget class and inheriting from widgets.dom widget, we can create the Python representation of our hello world widget. Here I create a traitlet called _view_name, and it's a Unicode traitlet with this special sync equals true attribute. And this is very important. Any traitlets with sync equals true are traitlets that get synchronized to and from the front end. Without this sync equals true keyword argument, the widget framework will ignore the traitlet and it won't be sent to and from the front end. This view name trait is actually a special name, and what this does is it tells the front end what view to render, what view to associate with your widget when it is displayed. So there are a bunch of different traitlets. Here I've listed a lot of them. I won't go over each traitlet. Earlier we talked about the model and view nature of Backbone when I showed you that little diagram and we displayed multiple widgets. The first thing that we need to do, and actually the only thing that we need to do, is define a view, because the model is provided to us by default with the IPython widget framework. The model that our Hello World widget will use is a generic model that gets updated to the contents of the Python model. So we don't have to define a mirrored model in the front end because that gets done for us. When we first display our widget in the front end, all those sync equals true traits get pushed to the front end and added to this generic model. So the only thing we need to do is define how our widget will be represented in JavaScript. So Brian mentioned earlier we use something called require. This is a way of kind of having Python-like import functionality in JavaScript. Here I require the widget manager. The next step is to define a view. So I create a view class, and this is kind of a funky syntax, but this is Backbone's syntax. So I create a hello view, and I call IPython.DOMWidgetView, which is our base class, .extend, and then I pass it a dict, an empty dict. And this part's also important. After creating that class, I need to register it with the widget manager so it knows where to find the class based on the view name. we need to provide a render method to get our view to be able to display on the page. So here I provide, I override the default render method, and what I do is I set the text of .l. And .l is something that's provided with widget views by default. It's just a handle to the widget, the base widget element, and you can do anything with it. You can change it. Any type of JavaScript that you could execute, you can do with .l, and that will update the widget on the page. So here I just set the text property of L to hello world. So if we, looks like it wasn't running the code. If we run all that, and then test it by just constructing hello widget, ta-da, we have our hello world. So there's some JavaScript running in the front end. Yeah?
For the sake of debugging these, can you access the list of registered widgets from the JavaScript console?
Yeah. IPython.widgetmanager.
I got that far.
It's like .widget underscore views, I think. Widget underscore views. It should be. Yeah. Oh, yeah. It can be done, and it's a static class level attribute. So you would do it on the capital W, capital M widget manager. Yeah. So the next thing, looks like we're already 5 minutes over. We'll go through this a little bit quicker. So the next thing is making the widget stateful. Here I add a value key, set it to hello world, sync equals true, very important. To access the model from the view that you've created in JavaScript, there's a .model property of the view, and that's just a handle back to the model. There are set and get methods of the model that allow you to set and get keys of the JavaScript model. And so here, what I do is I use this .model.get value to get the initial value of the model when the widget is displayed. Should we?
Yeah, because we have to give people enough time to get back from lunch. Okay. So as you can tell, we have a lot more content than even 4 hours. All of this content obviously is available in the IPython in-depth repository. Again, we'll be around this week. Please feel free to bug any of us on the IPython team. And
I'm willing to help anybody too if they want to create a custom widget. Like I'll spend some extra time tutoring widget creation.
All right, thanks.